What they come up with is this massive super transporter that looks distinctly odd, but that people very quickly figure out bears a resemblance to something else.
The beluga whale has got a pointy little snout filled with teeth. It has got a big round melon on its head. And when everybody looked at this new Airbus aircraft, they looked at it and said, that doesn't look like a plane. It doesn't look like a pregnant guppy. That looks like a beluga whale.
Almost immediately, the bulbous plane becomes known as the Beluga Super Transporter. And there's one key feature that separates it from the Guppy it's designed to replace.
The cockpit is much lower down than you would expect. And then there's this massive, great big hump stretching the whole length of the aeroplane.
The Beluga's odd looks come down to safety.
Now, the problem with the Guppy is that in order to load it, you essentially had to break it in half and then put it back together again.
Not only is this a slow and laborious process, but it's also potentially dangerous. It meant the flight control system, the cables running from the cockpit to the plane's rudder and control surfaces on the wings, have to be disconnected every time it's loaded.
The flight control system is the most safety critical system on the aircraft. Without your flight control system, you're not flying.
You've got connections being opened and closed constantly, so that's potentially a point of failure.
What they did to avoid this disconnection of the flight control system is essentially lower the cockpit and increase the volume above said cockpit, which gives it that iconic beluga head shape. It enables the cargo door to be opened from above rather than having to disconnect anything from below.
So on the Beluga, the whole nose pops up. You put your assembly in, you close the nose, and you fly the plane.
Airbus's ingenious new cargo loading redesign provides an added benefit. It cuts loading times in half. The plane can even be wheeled nose first into special indoor weatherproof loading bays.
It's like a Formula One pit stop. Everything is ready to go and organized. These platforms that lift and then allow you to roll your wing in means that you can unload and reload a Beluga plane within less than an hour. To do it with something so big, so complex, really is a work of art.
The Beluga enters service in 1995. Soon, 5 of these flying giants are helping to transport and build hundreds of new aircraft each year. By the 2000s, Airbus are riding a wave of success.
Airbus's order numbers are coming up to rival Boeing's. You're seeing the gap narrow between an established player in America and Airbus in Europe.
But behind closed doors, the American powerhouse has been preparing a counterattack. A revolutionary new plane designed to reassert its dominance and shake up the industry as it enters a new millennium.
It's my pleasure to welcome you to the certification ceremony for the Boeing 787 Dreamliner.
In 2011, the Boeing 787 Dreamliner enters commercial service. Built with decades of experience, it rethinks long-haul air travel, combining the range of big passenger planes like the 747 jumbo jet with the accessibility of smaller, two-engined aircraft.
747 has 4 engines because it needed 4 engines to get up and stay up. Now, you can do that with 2 engines. It's much more economical.
Overnight, the Dreamliner shatters the status quo of the airline industry, opening up thousands of new long-haul routes by flying directly between smaller airports. Airbus is forced to respond.
When Boeing comes up with the 787 Dreamliner, Airbus obviously wants to rival them, so they start developing the A350. It will be phenomenal. It will take nearly 500 passengers. The range will be huge.
The A350 will be able to fly long haul on efficient twin engines and carry more passengers than the Dreamliner. But before Airbus can start mass producing their new plane, they have a snag.
You have a bigger fuselage, bigger mass, you need bigger wings to create that lift. And because of that, you need much bigger transportation space.
Like NASA before them. To transport parts for their new airliner, Airbus need to make an already giant plane even bigger. The Beluga XL.
This thing is double the size of the original Super Guppy and 30% bigger than the original Beluga.
The Beluga's fuselage is now a colossal 35 feet high. That's equivalent to a 3-story house flying through the air. Airbus once again smashes through the size barrier, pushing the XL into uncharted terrain with new perils.
To make the Beluga even bigger, there were a whole bunch of challenges that the designers needed to overcome. Because it's a bigger aircraft, it's now more susceptible to crosswinds.
Crosswinds blow directly across planes at a 90-degree angle, threatening their stability.
Crosswinds are particularly a challenge during the takeoff and landing phases of an aircraft because the aircraft has to be traveling in the direction of the runway. A crosswind makes it want to change the direction and become misaligned with the runway.
There's a tried and tested technique that pilots use to overcome strong crosswinds: crabbing.
As you come down to the runway, you're going to be going sideways. As you get to touchdown, you have to correct that because you can't land with the wheels going sideways. It might be a bit unnerving if you're a passenger, but it's something that we train for.
But due to the Beluga XL's sheer size, crabbing alone won't be enough. Its cargo hold is now so big, on gusty days, it will catch the wind like a sail, making it impossible to land.
A lot of the places where Airbus has its biggest factories are in coastal locations, very exposed to the harsh weather of the North Atlantic.
For much of the year, the XL is in danger of being grounded. Without a solution, Airbus's intricate logistical network could come grinding to a halt. Airbus's engineers go back to the drawing board. The Beluga's vertical tail fin is enlarged to a total height of more than 30 feet, providing a huge surface area to resist unwanted rotations.
And it also needed these auxiliary fins sitting at the end of the horizontal stabilizer. That if the aircraft becomes misaligned, if a crosswind gust takes it away from flying directly into the wind, those big vertical surfaces pull the aircraft back and realign it with the oncoming flow.
Finally, ventral fins are added at the bottom of the fuselage.
As you see in boats, they have surfaces that come down to enable them to stay stable, and it's exactly the same principle.
With its uniquely modified tail fin, the Beluga XL can land safely even in strong Force 6 crosswinds, allowing it to keep up with its predecessor's demanding year-round schedule.